berguna dalam bidang kejuruteraan dan sebagainya lah. So ini one of the system yang di develop lah. So the last one being designated as 10 MIL STD105E. So in 1973, it was adopted by international organization ISO. Have adopted this system. So and it was given this number lah. Okay, so it was developed for government procurement. Then it has been standard for attribute inspection for industry. Okay, so government maksud sini dalam US government dia banyak gunakan contohnya dalam military. Dia procure, dia beli banyak komponen dan juga supplies daripada bekal-pembekal. So they want to have a system to make decision. Okay, to make decision. So this is acceptance sampling system yang kita pakai hari ini pun sangat digunakan di industri-industri. MIL 105E. Okay, most widely used acceptance sampling system. So it is the most widely used. Okay, the most widely used acceptance sampling plan in the world. Okay. So jadi yang kita lihat sekarang ini digunakan di industri ya, di industri pun menggunakan teknik ini. So there has been modification to it. Okay, MIL STD ini telah dimodify by American Society for Quality, ASQ. Okay, this is a professional body lah, and it is known as ANSI Z1.4. Okay, Z1.4. So that's why you see here Z1.4. So this is basically coming from MIL STD 105. Okay, with some modification. And so what are the changes? So basically majority of the things are still the same. Okay. So the table and procedure is still the same, but there are some basic definition lah. For example, kita dah bincang sebelum ni, non-conformity and non-conforming unit are being replaced by the word of defects and defective. Okay, that is used in the system tersebut lah. And also ada switching rule lah. The switching rule that use a limit number for one of the reduced inspection criteria is an option. Okay, there is a switching rule. Okay, maksud switching rule kat sini, I will explain more detail on that switching rule. We can switch either using single sampling, cara Titan inspection, ataupun reduced inspection, ataupun loose inspection. We can do that switching. So switching is one of the aspect in application of the sampling system lah. Okay, I think there is some discussion here on that switching. Let me check ada tak. Tak ada sini, tapi mungkin dalam e-book kita pun ada that switching rule. How can we switch the inspection? Yeah, there is here. This is switching for, yeah, ada pun. Okay, switching procedure. Okay, switching procedure. How we can switch from one plan to another plan. Okay, kita akan bincang lebih lanjut lagi lah. And we have normal inspection, Titan inspection, and the reduced inspection. So when we can switch from normal inspection, become Titan, from Titan to normal. Okay, from normal to reduce. Okay, for reduce to normal. How can we switch this scheme? So this is also some of the modification ataupun amendment yang dibuat oleh ASQ lah. Okay, so that is the switching rule based on limit number for one of for one of the reduced inspection criteria is an option. So dia buat some modification lah for the use of industry. It was a government document used in the military, and then it was modified for the purpose of industry. So additional modification seterusnya adalah additional table. Okay, additional table is added, A, OQL, LQ, ASN, and so on. This table reflects some performance which are combination of that. Okay, so the standard is applicable, not limited to attribute inspection. Okay, so can be used for an item, for finished product. It can be used for raw material. It can be used inspection during operation. It can be used for material in process, for supplies in storage, maintenance, operation, data, administrative procedure, dan sebagainya. The assembly plan of this standard are intended to be used for continuing series of lots. Okay. So, but the plan may be designated for isolated lots by consulting operating characteristics. So, operating characteristic curve is a curve that we use to describe performance of the sampling plan. Okay, contohnya operating characteristic curve ni adalah contoh di sini. This is what we call it operating characteristic curve. Okay, operating characteristic curve where we describe how good is a particular sampling plan. Okay, dalam sampling plan, selain kita ada single sampling, double sampling, multiple sampling, we also have what we call it a procedure to determine normal inspection, tighten inspection, ataupun reduce inspection. So, how do we implement this? Okay. So dalam sistem ini seperti yang kita lihat, dia ada single sampling, double sampling, and multiple sampling. So for each of these, katakan single sampling, you have a choice. Okay, single sampling. For this single sampling, ataupun double sampling, you can start the sampling by using what we call this in normal inspection. Okay, you can start with normal inspection, and you can, from normal, you can change it to reduce inspection. Kalau performance is improving, okay, you dapati tak ada rejects ataupun very small reject, you can reduce the inspection. Kalau you do the normal inspection and dapati the result is a lot of rejects, so you have to tighten the inspection. Okay, you have to tighten the inspection. Maknanya pemeriksaan lebih ketat lah. Okay, so katakan we start with normal inspection. Okay. And the quality is improving, very little is reject, so you can change to reduce inspection. Okay, but if the performance getting worse, you have to make it tighten inspection. Okay, pemeriksaan yang lebih ketat. So that is flexibility yang diberikan dalam sistem acceptance sampling ni lah. So tighten inspection is used when producer recent quality history deteriorated. Okay, maknanya prestasi pemeriksaan dia merosot. Okay, prestasi merosot. So common sense lah, bila merosot kita buat pemeriksaan lebih ketat. Okay, so acceptance requirement under tighten inspection are more stringent. Okay, lebih ketat than normal inspection. And reduced inspection is used, okay, when the recent quality history has exceptionally good. Okay, kita buat inspection dan dapati jarang sangat dapat reject. Jadi kita boleh buat reduced inspection. So figure 10.1 illustrate the differences between among the OC curve. Okay, OC curve. This is what I showed earlier. This is what we call it OC curve, operating characteristic curve. Okay, what is operating characteristic curve? Ialah satu lengkong operasi kecirian di Malay. Operating characteristic. The operating characteristic curve operating characteristic ataupun lengkong kecirian operasi operating characteristic curve ialah satu curve which is to describe how good is that particular acceptance sampling, how effective is. So if you see here, this vertical line is we call this percentage of lot acceptance. So basically this is probability of acceptance lah. Probability kebarangkalian menerima. Probability of acceptance. On the vertical axis, this is how much is the non-conforming in terms of percentage. For example, if you have 10% products which are bad in the lot that you are producing and send it for inspection, so the chances it to be accepted is very low. Chances to be accepted is very low. So for example, you have a very small percentage of defects in the production that you send for acceptance sampling. The chances to be accepted is very high. Almost 100%. It could be 95%, could be 98%. So this is what the curve is showing. Any question up to this point?
Doktor boleh tolong explain balik tak curve ni? Saya tak clear.
Operating characteristic curve, ialah lengkong kecirian operasi bagi acceptance sampling. We want to know how good is the sampling. Or acceptance sampling. How good is the acceptance sampling? Because we have many choices in doing the sampling. We can have single sampling, we can have double sampling, we can have multiple sampling. So, but in this case, as I explained, of all the sampling plan, either is single or double or multiple, you have a choice to switch. Switching your sampling. Normally, we start the inspection by using normal inspection. So when the inspection is getting improved, the quality is improved, you have very little reject. Let's say you inspect 100 lots and only one lot is reject. So you can say, so this is a good performance. You say, I want to reduce the inspection. Reduce inspection meaning that you can take less number of samples. Or you dapati 100 lot diperiksa, dapati 10 lot adalah reject. So this is a high number. So you can say, I need to switch to tighten inspection. Pemeriksaan yang ketat. So this is different plan, this is different plan, and this is the different plan. So now you want to know, what are the probability of acceptance if we are comparing this plan, the normal inspection plan, reduced inspection plan, and tightened inspection plan. How it is the performance? What is the chances to be accepted if we are implementing different alternatives? Secara logiknya, when you have high percentage of defects, there will be lower chances to be accepted. Like in this case, percent non-conforming maknanya peratusan benda yang rosak. Saya bagi contoh sini, katakan you have that in these are your production. I just put it as a dot kat sini. Let's say this is what you produce. And then these are you produce. So when in the production, it's not possible to produce 100% perfect. There will be small percentage, some defects inside here. Because your inspection is sampling, they might be missed out. Dia termasuk dalam penghantaran kepada pelanggan. So, jadi nak buat inspection mana? Is it not normal inspection? Or you want to have tighten inspection? Okay. Pemeriksaan ketat, which is costly ya, tighten maknanya pemeriksaan ketat ni, ataupun pemeriksaan loose inspection atau we kata reduce inspection. Loose inspection. So, jadi kita nak tahu which one, what is the effectiveness of all of this. So ini diterangkan oleh operating characteristic curve. Okay? Operating characteristic curve explain how good is the sampling plan. So jadi how to demonstrate this effectiveness, we can have a chart, we call it OCC, operating characteristic curve. Okay, later on you're going to learn how to construct a chart, this chart. So we have probability of acceptance, which is 1 is a perfect acceptance lah. Kalau 0 is perfect rejects. So in between you have 70, any numbers lah, 99, 98 and so on. But in this vertical line, we just put it some numbers, 25%, 50%. So this is percent log acceptance, maknanya probability of acceptance lah. Okay, so we put it in terms of percentage, it will be the round number lah, instead of 1 and 0.75. Okay, for 75%, 0.5, okay, for 50%, because this curve, this line is multiplied by 100. That's what is shown in this diagram. So on the vertical axis, kita ada percentage of non-conforming. Maknanya, how much that the product are defects in this lot that you produce. Okay, you can have 2% defect, 3% defect, 4% defect, okay, 5% and so on. So, the larger the number that we have, for example, we take 10% defect. What is the probability of acceptance? Probability is lower compared to 8%. 6% percentage of acceptance is lower. This is the number that you get here. 10, so percentage of acceptance is only here, less than 10%. Katakan I referring now to normal inspection. Normally, we start with normal inspection before we switch to any of the other plan. So this is normal inspection, OCC curve for normal inspection. Okay, so in this curve, it shows that I think the plan was given, not mentioned here, but there is a plan that can come up with that curve lah. I think it's single sampling, but anyway, it doesn't matter. Apa yang penting adalah the characteristic of this. So normal inspection. So if we have low inside this sample that we send to our customer, if you have a low percentage of non-conforming, okay, so the chances to be accepted by customer is very high lah. The titik adalah somewhere here. But if you have high, the chances of your customer to accept is very low. Okay, so if we compare, if we have normal inspection plan and tighten inspection plan, so we see that, okay, if you have 4%, let's say 4% defect in the lot, you use normal inspection. Okay, so the chances to be accepted is somewhere here, maybe around 40%. Okay, 40%. But if you use tighten inspection, chances to be accepted is lower. Okay, the chance is only maybe 15% here. But if you use reduced inspection, okay, this is reduced, R is reduced. Okay, reduced inspection, the chances for that lot to be accepted is higher. Is here. Okay, so reduced inspection, chances to be accepted is higher. Okay, relative to normal inspection. If tightened inspection, the chances to be accepted is lower. Okay, this curve, this is what the curve is showing. So it's showing at different percentage of non-conforming. Let's say if you are having about 6% inside this, 6% adalah defect. So maybe you can ask, why you need to put defect in this shipment? Nobody knows actually, is there a defect or not? But this is based on probability, because we know that it's not possible to have 100% because there will be some components which are defects goes to the products because we use sampling. Okay, some are missed out. We are not able to detect. So, jadi, but in long run, we know exactly, I mean, roughly lah, we know roughly what is the percentage that of the defect that is being produced by that production system. Let's say 6%. 6% are defects. Which one? We don't know. But that lot, okay, that we've supplied to our customer will have 6% defects. So if you use reduced inspection, chances to be accepted is somewhere here, okay, which is maybe around what, 30 or 40%. But if you normal inspection, chances to be accepted is somewhere here, lower. Okay, if you tighten, most likely all of the shipment will be rejected. Okay, is it okay? Clear? What is operating characteristic curve?
Clear dah.
All right. So this is how we can evaluate ataupun what we can decide lah which one that we want to use because dia effect dia lah cost. Okay. So all right. Okay. So this paragraph is telling us that number of inspected under reduced inspection is less. Okay, when implement reduced inspection, kita menyemak kurang. The number that we need to inspect is less compared to the normal inspection. Okay, the decision as to the type of plan to use, is single, double, and so on, is left to the responsibility authority. Who decide that? Okay, it could be customer, or you can get the agreement with your customer that we want to implement which one, either single ke, ataupun double, ataupun multiple. Okay. So get the agreement, which one they want to be accepted. This is important that you can put this statement of inspection, acceptance sampling in the buying or when you are doing procurement. Okay, you are ordering something, you may have to make agreement with the supplier. Okay, customer and supplier must have agreement. Otherwise, there will be some dispute. Dispute ni maknanya sesuatu pertengkaran berlaku lah. Jadi pertengkaran dalam industri ni melibatkan kos dan court cases lah. Boleh masuk kes mahkamah pun. Sebab apabila you reject, okay, pihak pembekal akan kerugian. Pembekal kalau boleh dia nakkan all the shipment to be accepted. Okay. But in your case as a customer, you want it all good items. Okay, you don't want to accept bad items. So we are talking about supplying material maybe costing a lot of money, a lot of money. So we must have a proper system. So normal inspection is used for the start. Okay? For the start, we use normal inspection. Okay? So which can be changed to tighten or reduce, okay, after some historical result that we obtain lah. Okay, so non-conformities and conformity are classified in a group such as ABC or critical, major, or minor. Okay, in this notes, we have this table. Sorry, dia punya rajah dia lari sikit. This is what we call it sample size code letter. Okay, so previously when I explained single sampling, double sampling, I just say that take 10,000 as a lot size. Okay, N equal to maybe 95, C equal to 3, and reject equal to 4 contohnya. That one is just we already assume that we already know. But actually we need to select what should be the sample size, what should be the decision criteria. This is coming from acceptance sampling system. One of the system is showing here, okay, where we use, okay, these are inside the system yang kita kata Z1.4 tadi lah, acceptance sampling system. The batch size is given here, the lot batch size. Kalau batch size ni adalah 9,000, okay, macam what we have done earlier, 9,000 is somewhere here. Lot size means that we produce 9,000. So we have a choice here. These are the choice that we have. Okay. So this is we call sample size code letter. The code letter can be C, can be D, F, G, and this has a meaning. They have a meaning. So we also have to decide what type of inspection you want to do. Is it inspection level, special, or general inspection? Okay. Is it level 1, level 2, or level 3? Okay, because whatever you choose will influence the code letter, okay, sample size code letter. Okay. Let's say if you select general inspection, you ambil level 2 contohnya. Okay, the code level will be 6. Okay, don't worry much about apa maksudnya. I just want to show how to use the table. Let's say you get letter L. You decide general inspection level, level 2, lot size is 9,000. You fall between this, so you're going to have L. L is, what is L? L is sample size code letters. And then what you do with that? Then we move on with the L. Okay. So this, okay, try to, saya pusing. Boleh pun. Okay. So that is single sampling. This is the table. Okay. In this table, you have sample size code letter kat sini. Okay, everyone, you already have this PDF. I already sent to your your Telegram. Okay, you can download. Your Telegram already have. So now we have single sampling. Let's say I decided to use single sampling. So the code letter was L. So this is where I enter in this table. What it says here, sample size should be 200. Okay, and this is normal inspection. Okay, based on normal inspection. So let's say I produce the lot size of 9,000. Okay, based on that table just now. Okay, 9,000, and I found out that the general inspection level 2 give the code letter of L. Okay, code letter of L. So now that's where you get here. Code letter of L say take 200. So maknanya you only take 200 out of 9,000 that you produce as your sample. Okay, ambil 200 saja. So everybody will have to follow this. Otherwise, you can get a dispute with your supplier because there is no reference. So we still can reuse this. Okay, now where is our decision? Okay, so acceptance. Okay, siapa ni bunyi? Okay, so we have acceptance quality limit. Okay, for normal inspection there. Okay, acceptance quality limit can be from the smallest here to the large one. So you can have AC and RE in this table. Okay, AC meaning the acceptance number. Okay, RC meaning the non-acceptance number, the reject number. So as it is shown here. So what is showing here? AC. Okay, so you have your AC, okay. All the AC are RC, RC. I think what they're using in this table is RC. No, RE, reject lah, basically reject. Okay, reject number and accept number. Okay, so let's say you have decided to have 2.5, okay, as your acceptance quality level or acceptance quality limit. So if you have that 2.5, okay, 2.5, okay, 2.5. So We have it 200 here. So we just follow this. Follow this. So you are meeting here, somewhere here. Okay. So what it shows here, you take that 200. Okay. So if you found that the effective units or non-conforming units, non-conforming, okay, non-conforming, okay, the non-conforming unit adalah 10 or less, okay, dapati yang rosak, bilangan yang rosak from the inspection, after doing inspection of 200 units, okay, you found that non-conforming was less than equal to 10, okay, you will accept. Okay, how much you accept? You accept all the 9,000. Okay, you accept all 9,000 will be accepted. Okay, if non-conforming was greater than or equal to 11, why 11? This is 11. Okay, it's reject number. Okay, reject number. 11, you will reject. How much you reject? Reject all 9,000. Okay, any question? Is it clear?
Doktor ni untuk single sampling je kan?
This table is only for single sampling. There are also tables for double sampling. There are tables for Titan inspection, and this is single sampling, normal inspection. So jadi you have to be careful. Look at the table lah. What type of inspection? Okay, in this case, in normal inspection, single sampling. Okay, so this is to guide us to decide how much to take and how to make decision. So this can avoid any dispute. Okay, perbalahan dengan pembekal dan pembeli lah. Okay, because if there is no document, this is international document, okay, widely accepted, so nobody can argue how accurate is the number. They have done it a thorough study to come up with this table. Okay, let's say you are having a different code letter. Okay, different code letter. Let's say that you have, okay, let's see, you have, okay, let's go and see different example ke atas. Oh, buku ni pun dah pusing . Okay. Okay, let's see the example. For example, you have this table, okay? Okay, assuming you are producing a lot of items, okay, more than 10,000. Okay, more than 10,000, let's say. Now you are producing 500,000 or 150 lah, 150, more is the number. Okay, between 35,000 and 150, that's a lot size, maybe small component. Okay, maybe injection molding process. So you have a choice, special inspection or general inspection. So let's say we start general inspection dulu lah. Okay, and the code letter size, okay, for the level 2 is N. Okay, so N, and then you go to that table again, N, N. Okay, so this table, so we find where is N. Okay, so N is somewhere here, N. Okay, so again,
Doktor ni
okay.
reduce.
Ini reduce inspection. Okay, tak apalah. Kita katakan kita guna reduce inspection lah. Okay, reduce inspection. Okay, reduce inspection. Ambil 200, and then katakan you are having 4% AQL. This is AQL. AQL. average quality limit, acceptance quality limit for normal inspection. Okay, you dapati, you nak ambil katakan 4%, 4%, 4%, and then you go to this line, dapati dia jatuh di sini. Tak ada number sini. What you do? What you need to do now? Okay, so meaning that you have to follow the next one. Okay, 10. Okay, accept number is 10. Okay, so the reject number is 13. Okay, so from the sample that you take 200. Okay, 200. Okay, maybe your lot size tadi berapa? 150 150 euro. Okay, so now you have a number between what happen if you have 11 defect non-conforming unit and 12 non-conforming unit. What you need to do? Because the number accept is 10 or less, reject is 13 and or more. What you need to do when you have 11 and 12? Okay, remember you are doing reduced inspection. What you need to do now? Anybody? Anyone?
Double sampling.
Okay. You have to take second sample. Okay, second sample because you cannot decide. Okay, after the first sampling, you need to go for double sampling. Okay, so we proceed for double sampling in this case. Okay, so this table guides us how to select. Right. So let's see more detail of. Okay, in this table you can see you have single sampling for Titan inspection. Kalau Titan inspection for the system that you have seen just now, you have 4% of non-conforming kat sini ataupun kita panggil acceptance quality limit lah, 4%. And then tadi berapa nilai tadi? N tadi kan? Betul lah N Okay, it was N 200 kan? N 200. So now N will be 500. Why 500? Because you are implementing pemeriksaan yang ketat. Okay, pemeriksaan yang ketat. Kalau N pada pemeriksaan yang normal atau reduce 200 sahaja. Only 200 only needed. Okay, decision adalah 10 and 13. But in this case, when you tighten, you have to take more sample, 500, and your decision is somewhere here. Okay, in order to accept, okay, sebab arrow ni berhenti kat sini, you have to move to the next level. In order to accept, you must have 18. Okay, to reject is 19. Okay, because the sample is 500, big sample. Okay, big sample. Of course, the decision criteria sini pun big jugalah, 18 and 19. So there is no gray area. Okay, you must decide. So this is advantage of using Titan inspection. No need to go for second sampling because decision must be made because you already have 18 and 19. There is no gray area. Okay, let's say what happened if you use normal inspection. Okay, normal inspection. Okay, what is the, how many sample you have to take if you are using normal inspection? The code letter size is N. Okay, and you have, let's say, 4% here. How many sample you have to take? Okay, let me ask. I want to make sure that people are listening and have the understanding. Okay, Amirul. Amirul? Ada tak ni Amirul ni?
Amirul mana doktor?
Keluar nama seorang je ni Amirul kat sini ni. Okay, tak apa. Respond to chat box. Anyone? I want to know how many sample you should take. Okay, please respond to the chat box. How many sample you should take? Okay, 500. Okay, so we take 500. Okay, so our accept number will be somewhere here, but since it's not, there's no number here, so we move to the next one. Okay, which is 21 and 22. Okay, 21 and 22. So you see, kalau Titan tadi 18 dan 19. Okay, so maknanya dia lebih ketat berbandingkan 21 dengan 22. Okay, 18 and 19. That was for Titan inspection tadi kan. Okay, but now for normal inspection, okay, you need okay, Titan inspection you need 18 dan 19. Okay, 18, 19. Normal inspection 21, 22. Okay, so we have reduced inspection. Okay, reduced inspection, and then this N, and kat sini 500. Okay, we take sample of 500. Sini pun 500 juga. Okay, for reduced inspection tadi 200 kan? Okay, 200. So for reduced inspection 200, and your decision is 10 or 13. Okay, 10 and 13. Okay, so if we see here, okay, reduce, yes, you have reduced number of inspection. Okay, you are producing the same lot lah, but we have 3 choice, which one to choose. Okay, take 200 using reduce, but decision is if you have 10 or less, you accept. More than 30, 13 and more, you reject. Okay, so there is a gray area where require second sampling. So if you implement normal, okay, normal inspection, so to accept it, okay, you must have 21 or less. Okay, 21 or less. To reject it, you have 22 or more. So if we compare to Titan, 18 sudah kena reject lah. Okay, maknanya lebih ketat lah berbanding dengan 21. Yang ini kalau 21 pun boleh terima lagi. 22 kena reject lah. But kalau Titan 18 dah reject lah. Boleh faham? Is it okay? How we can compare Titan, normal and reduce?
Doktor,
Ya,
saya tanya yang untuk yang Titan tu dia bukan 19 ke yang kita akan reject atau 18?
Titan adalah 19. 19
reject.
reject.
Okay, baiklah. Terima kasih, Doktor.
18 is accept. Okay, 18 accept. Okay, so the accept number kat sini lah. All these are accept number. Okay, reject number is kat sini. Okay, so this is a sample number. So okay, how much you produce tadi lah kita kata N tadi kan, N dalam range yang tadi. Tak silap saya range tadi adalah 150K. Okay. Let's say you produce 150K, maybe a small component lah, maybe some injection molded parts. Okay, masuk dalam container, hantar kepada customer. So jadi sekarang customer nak decide, takkan nak check 150, ni mungkin makan masa 3 bulan buat selesai nak check. So what we do, we decide, okay, we take acceptance sampling. Okay. So what is the method to make decision? Inilah caranya. Okay, that's what I'm explaining now. Caranya ambil acceptance sampling based on Z1.4. This is a established international standard. Okay. Right. So let's understand a few more concepts. I think now it's 11:50. Yeah, we take 10-minute breaks dulu sebelum tu. Boleh? Kalau ada soalan boleh tanya sekarang, and kalau tak ada soalan, you can go for break 10 minutes and we continue at 12. Okay, any question?
No.
Okay. Can we continue? Okay, someone please respond to me. Can we continue? Okay, yes, thank you very much. All right, so we need to understand. Okay, do you see what I'm saying? I'm sharing now, right, on the screen. You see that your ebook, your PDF lah. PDF. Kenapa jadi macam ni? Alright, so AQL, okay, acceptable quality limit. In the table just now, we see there is a term, they call it acceptable quality limit. So what is AQL? Okay, so this is what we see just now from this table. Okay, there is a term being used in this table, AQL. Okay, you see here, acceptable quality limit. Okay, acceptable quality limit. Okay, you have a range of 0.01, 0.15, and so on. So this number is very important. Okay, AQL number is very important. This sample size code letter also important. Why? Because based on these two, we will decide. Okay, we will decide what is accept number, what is reject number. Okay, so what is AQL then? Okay, what is AQL? We already know that how to get the code letter sample size, but now we also need to know what is AQL. Okay, so AQL, okay, as shown here, it is acceptable quality level. Okay, acceptable quality level, most important part of the standard. Okay, in addition to sample size code letter lah. So maksudnya AQL are the worst tolerable process average, the worst quality level lah that we can accept. Okay, we can accept to be what do you call it? Yeah, in the process, the most tolerable, the worst tolerable. Okay, how much that you are able to tolerate? Okay, the bad products to go into your production lot. Of course, we want it 100% good, but it's not possible. Okay, but when it's not possible, how much you are able to tolerate? Is it 1% defects, 2% defect, 3% defects? Okay, the lower defects, meaning that you are having good machineries, you have good workers, you have good material used in the process. But as the facilities and machine getting older, okay, some product might be deviate from the standards. Okay, so some bad products might be produced. Okay, there will be some instability in electricity power, contohnya. Okay, there might be some material inconsistency in the material. Okay, there will be some problem with the workers, okay, getting tired and then not serious in doing the work. Might also affect the quality that what you produce. Okay, so AQL is the worst tolerable process average. Okay, when a continuous series of lot is submitted for acceptance sampling. Okay, so in the standard, okay, when we use percent non-conforming plan, AQL is ranging from 0.1%, okay, until 10%. Okay, 10% is considered high, very high of non-conforming in the production lot. Okay, so non-conforming per unit plan. Okay, we use non-conforming per unit plan. AQL are possible from 0.01 non-conformities per 100 unit to 1,000 non-conformities per 100 units. Okay, depend on how you measure that percentage lah. Okay, kalau we are using percentage of non-conforming, we are using this number. If we are using non-conforming based on 100 unit, okay, 100 unit, per 100 unit, we count it for per 100 unit. So the values between 0.01 to 1,000. So that's why in this table, you see this table, you have that number up to 1,000. Okay, you see this 1,000 here. Okay, so this is used in the case of where your non-conforming is recorded in terms of per 100 unit. Okay, per 100 unit. So coming from 0.001 until 1,000. But if we use percentage of non-conforming, this will be the useful range lah. Okay, between 0.01 okay until 10. Okay, until 10. So in that range. Okay, so understanding of this is very important for us to enable us to use, okay, to use the standard. Okay, so we have it 0.01%. Kalau we put it in terms of percentage, and the maximum is 10%. If you have another unit to express non-conforming, it coming from 0.001, it's same number. If we are counting it per 100 units, okay, so the maximum will be 1,000 non-conforming per 100 units. Okay, so this AQL has to be put in the contracts. Okay, your contract with the supplier. Okay, different AQL may be designated for groups of non-conforming considered collectively for individual non-conformities. Okay, all right. So how you decide AQL then? Okay, who knows about the right AQL? So it will be based on historical data, based on the previous experience that you have been producing the product. If you do 100% inspection, roughly how much that you found that the highest non-conforming that is available in that production lot. So maybe not from 100% inspection, maybe from previous experience. Okay, if you found out that your production is very good, okay, your AQL, maybe you put it a lower value, okay, to ensure that the product is, to show that you are able to produce a good quality level. But if you put a high, of course, it's not good impression to the customer. But if your output has high level of non-conforming, but you put it low, chances to reject is very easy, very easy. So somehow that have to be done based on historical data, or empirical judgment, or maybe based on your engineering knowledge. With respect to safety, okay, and experience in testing, live testing, and so on. Maybe experimentation by testing lots of various percentage, okay, or based on producer's capability, your capability that you know that you have been working there for some time now. You know the capability to produce, okay, or some situation customer requirement, customer decide, they also can, okay. So it is frequently practiced to use AQL of 0.1%. Okay, this is common practice to use AQL of 0.1%. Okay, it's common practice, 0.1%. Okay, this is for critical item. Okay, critical item, you cannot have high percentage of defects. But for major items, which is Okay, you can still use if it is the non-conforming is there, but less functioning. For major item, it's at 1%. And of course, for minor, 2.5%. Okay, so the inspection is maybe for more cosmetic, based on color, that doesn't affect the function of the product. So you can tolerate to have 2.5% of appearance defects. Okay, appearance defect 2.5%. But if you are having component which are need to be, you are doing inspection for quality characteristic which is functional. If it is broken, okay, the product cannot be functioning. Okay, maybe related to, let's say, the wiring of the switches. If the wiring is detached, okay, the equipment cannot be used. So the inspection for that wiring, you cannot have defects more than 0.1%. Okay, because if there is some, there is non-conforming for that wiring, soldering of that wiring, the product cannot be functioning. So you put that AQL high, you mean the expectation should be 0.1% of the defects. Okay, compared to you just inspection of appearance. Appearance could be scratch, it could be maybe some color, uneven color, which does not affect the functioning of the equipment. Okay, but for major type of defects, which the product still can function, but maybe it will affect the performance functioning, but the performance is not optimal. Okay, this could be katakan example. You may have a hole in the cover. Okay, you have equipment. The equipment has a cover is to protect the component inside. The cover there has a small hole. Okay, so it still can functioning, but the hole in short term maybe not effective, but long term maybe the hole can create other problem. Maybe some water can go in. Okay, so when it's getting serious, it will finally disturb the function of that equipment. So you can put it as a major defect. So if such defects, you can put it the limit of AQL is 1%. Okay. Okay, in terms of selecting sample size, okay, selecting sample size, we have a choice here where we have general inspection level 1, 2, and 3. And we also have that special level where we have inspection level, different level inspection provide approximately the same protection to producer but different protection to customer. Okay, inspection level 2, which is a norm, okay, with level 1 providing about half amount of the inspection, and level 3 providing about twice the amount of inspection. So this level of inspection, if you see here, the level inspection, it is related to number, how many to select. Okay, how many, level 1, level 2, level 3. Okay, if we see between, let's say we take another example, same example tadi ya. Katakan kat sini ya, kat sini. Let's see, if we take level 1 is going to be J, level 2 it will be L, level 3 it will be M. Okay, J, L, M. Okay, J, L, M. So if we go here, J, L, M. So what is J? J, L, M. Okay, so if we take level 1, we just only require 80. Okay, if we take level M, it's 200. Okay, M is 315. Okay, so That's how that different level will influence the number of sample that we should take. So normally, but we start with level 2 lah, in the middle there, level 2. And same thing also, let's say we compare this. Okay, this will be 5, 6, L will be 10, 11, M will be 14, 15. Okay, because bigger sample size. Okay, is there any other things that we need to clarify here? Okay, for inexpensive item, okay, bagi item yang tak mahal lah, yang murah-murah. And for destructive testing, because it's cheap, you can do destructive testing where the item can be, put in testing that require to break the item. Maybe you do some crash testing. So after you have the crash, the item rosak lah, cannot be used. So because it's not expensive, you are able to do it. But if you to do crash on expensive item, going to be costly. Yeah? So, and also for harmful testing, level 3 should be considered. Okay, we use level 3 when it is destructive testing. Okay, level 3. Sorry, level 2. Okay, level 2. Level 2 for inexpensive item, destructive testing, harmful testing. Okay. So what is the effect here? You see that this is the effect of different level. Okay, level 1, level 2, level 3. If you see level 1, okay, level 1. Let's say the level 1 you are using 4% non-conforming. So chances to be accepted is very high if you are using level 1. Level 2, somewhere here is moderate. Level 3, chances to accept is very low. Okay, somewhere here. So chances to accept level 1 is higher. So this is relatively number of items to be inspected. So if level 2 is, let's say, 100, example, 100 sample. So for level 1, you need only 50. Okay, level 1, you need only 50. But for level 3, you need 200. Okay, more sample should be taken. And it's very difficult to be accepted. Okay, very difficult to be accepted. So as you know that level 2, it was recommended for expensive, for barang yang murah lah, okay, inexpensive item that require destructive testing and so on. Okay, for special level, okay, before that, I need to highlight here. For complex item, the item that are complex and expensive, okay, you go for inspection level 3. Okay, inspection level 3 for expensive item. Level 3, yeah, expensive item. So you see that chances to accept is very difficult. Okay, because of course, when you spend a lot of money, you want a good item. You don't want the bad item to go into the inspection. To go to the customer. Expensive item, okay, the customer should get almost perfect in terms of quality. So the chances to be accepted for poor products, okay, is very difficult, okay, very low. Okay, so you see that's why this is expensive item here, 4%. Okay, the acceptance is very low compared to the item which are not expensive. Okay? The acceptance is high there. Okay, so this is the purpose of using different level of this inspection level. Okay, for special level, we have S1, S2, S3, and S4. Okay, as shown in this table. Okay, so this is special level inspection. Okay, this is general level inspection. Special level inspection may be used when relatively small sample size are necessary and large sampling risk can or must be tolerated. When there is high risk, the sampling risk. So we use, for example, you don't have enough sample. Small sample size. Okay, sometimes you cannot take a lot of sample because it's expensive. Taking a lot of sample is expensive. Okay, so you go for special inspection. Okay, special inspection. So let's see, we take it here B. Here B compared to taking a C. Okay, B and C. What is the difference? Or even we take it. Oh, okay, that's okay. We can take B and D. Try to compare B and C. B and C. Okay, B and C. If we look in this table, here we have B and C. This is B, which is required sample size of 3. Okay, remember, this is small sample size. Okay, C also small. Okay, 5 only. Okay, so if there is anything fall within this range, you just take the closest one, point down, point down. Let's say yours is only 4% EQM. So 4% it will be 0.1 here. And the C also 0.1. Okay, this is kebetulan only 0.1. Maknanya to accept you must have 0 defect, 0 defective units or 0 non-conforming. Okay, to accept. To reject one already defect or one already non-conforming, the whole thing will be rejected. Okay, so we can see that how different sampling is planned. So we are lucky because somebody else already prepared for us this table. We just use it. Okay, so as special sampling plan is when there is small size, small sample size. Okay, so we have here special level. Okay, when small sample size. Okay, and there is high risk. Sampling risk is high. That's why the decision just now is 0 to 1. You can accept only when there is no defect. You do inspection. Take, for example, 3 samples. Okay. If you found only 1 defect, you reject the whole thing. Okay. You take 3. You found there is none of the 3 defective or none of these are non-conforming. You accept all. Okay. Okay, AQL and sample size calculator. Okay, I think we have discussed that. Basically, what we have discussed is summarize here. Okay, summarize here. Determine the lot size and then determine inspection level. Usually level 2. We start with level 2 and we can change to other level based on the situation. We enter the table and find code letter size. We have done it. We have determined AQL. And we determine the type of sampling, is it single sampling, double sampling, and we enter appropriate table to find sampling plan. So this is how we can use acceptance sampling plan. All right, samplings, single sampling. I think this is just example. You can read on your own. basically I have explained already this. Okay. So the switching rules. Okay, switching rules. Okay, the switching rules. Okay, unless otherwise directed by responsible authority, okay, inspection start with normal inspection. Okay, we start with normal inspection. Start with normal inspection. Okay, normal, tighten, or reduced inspection will be continued unchanged for each class of non-conforming or until the switching procedure is given. We will require a change. If we continue with this, either any of these, until we are given permission to switch. Okay, switch to tighten or switch to reduce inspection. Okay, so what are conditions that allow us to do that? Okay, so what are the conditions that allowing us to do that? So let's say we are now in the normal. We want to switch it to, that to tighten. Okay, from normal we want to go to tighten. So what situation allow us to do it? When normal inspection is in effect, tighten inspection shall be instituted when 2 out of 5. Okay, when 2 out of 5 of our lots have not been accepted. Okay, so let's say we inspect 5 lots. So 2 of the lots have been rejected. So now, meaning that now we are in normal inspection. Okay, so 2 out of 5 have not been accepted. So let's say this one is rejected, this one rejected, only 3 accepted. So now we have to now implement tighten inspection. Okay, pemeriksaan ketat. Why? 2 daripada 5 dah rosak. Dah tak boleh diterima. So, and what happened when you want to go back to normal? Because tighten inspection is tiring, expensive, low moral to workers, you know, pemeriksaan ketat. So when you are allowed to go back to normal? You are allowed to go to normal again. Okay, dalam keadaan when the tighten inspection is in effect, normal inspection shall be instituted when 5 consecutive lot of batch are accepted. Okay, so you want to go back to original, you must achieve 5 over 5. Okay, 5 over 5. Maknanya we inspect 5 lot, all the 5 are accepted. Okay, all the 5 are accepted and allowed to go back to normal inspection. Okay, you're allowed to go back to normal inspection. Okay, so this one accepted, this one accepted, this one accepted, this one accepted, this one accepted. Now we say, okay, you are allowed to return back to normal inspection. So less stressful, less stressful to the workers, to the management, because now it's less control. Okay, so that is scenario number 2. Okay, what happened that you think that you are doing well now? You want to get the privilege of reduced inspection. Okay, reduced inspection. You want to get more, I think more freedom lah. Okay, to have reduced inspection. Okay, you want to go from here to here to have a reduced inspection. So ini macam PKP juga lah, PKPD, PKP apa semua tu kan. Ada kawalan ketat, ada kawalan longgar. Sekarang semakin longgar lah. So in what situation? It's also based on numbers, kan? Number of cases. Less number of cases, you can have reduced control. Okay. So for the reduced control, so these are the situation for reduced inspection. all the following conditions are satisfied. So in fact, some of this concept being implemented dalam kontrol COVID, kita ada kawalan ketat, kawalan yang apa, macam-macam kawalan. Okay, can you share with me what are the stages of COVID control from daripada kawalan ketat kepada kawalan apa lagi yang kita ada? Anyone? Okay, can put in chat box. Okay, what type of control do we have? We have PKP, PKPB, PKPD, KPPP. Bagus. Okay, Muhammad Hazim, you follow this. Sama jugalah dalam control inspection kita ada macam tu juga. Kawalan ketat, kawalan normal, kawalan sederhana yang dilonggarkan. Okay, so same thing. Okay, why we have different category? Because it's expensive, okay, to have a very tight control. Very expensive. Everybody has to be alert. You have to have more manpower and so on. So konsep yang sama dipakai. Okay, you can see now, whatever you learn, okay, if you have different situation, not necessarily on acceptance, even in our real life, okay, dalam case COVID, the concept can be implemented. So when the situation improve, kawalan dilonggarkan. Okay, kawalan dilonggarkan. So, jadi konsep yang sama. So, jadi longgarkan itu berapa bilangan cases yang ada. Okay, cases has to go down to what level. Sama juga dalam acceptance sampling that we are having now. Okay, so if you want to reduce inspection, okay, kawalan yang lebih longgar, you should have 10 lots, okay, which was on the normal inspection, and all of the lots has been accepted. Okay, so jadi kawalan dia agak strict juga lah daripada normal. You are now in normal. Okay, you want to go to reduce inspection. So apa syaratnya? When you are in the normal, to go to reduce, you must have 10 lots. Okay, 10 lots must be, all the lot has been accepted. 10 lot, tak ada lot pun yang ditolak. Okay, all accepted. So when all the lot accepted, okay, you can change your acceptance sampling plan to reduce. You can change to reduce inspection when all 10 lot, all accepted. Another scenario is total number of non-conformities in the sampling from preceding 10 lots is equal to or less than the applicable number that's given in table 5, 10.5. So this table is, the decision is based on the table here. Okay, this table is the limit number of reduced inspection. Okay, so if we have number of sample unit for the last 10 lot, okay, how many, what are AQL level, so that this table will guide us. Okay, how many of the number, okay, that allow us to switch to reduce. Okay, number of sample unit for last. Okay, this is basically number of unit that we have inspected, number of sample unit. Okay, how many that we have inspected. Okay, accumulated for the last 10 lots. Okay, and then this is the criteria that allow us to switch. Okay, so the star here, you see a lot of star there, showing the number of sample unit from the last 10 lots of batch which are not sufficient for the reduced inspection. Okay, so in that instances, more than 10 lots or batches may be used for the calculation. Okay, so we need more sample. Okay, so in sequence that they have been on normal inspection and none has been rejected while in the original inspection. See, very strict rules given to reduce to from normal to change from normal to reduce inspection. Okay. So get the reduced inspection ni macam privilege lah. Okay, you get a privilege. Okay, kawalan yang tidak ketat. Okay, I think we almost done. Let me finish this part. Okay, another rules that we have is, okay, we have that just now. For example, for this switching from normal to Titan based on that 10 lots, okay, using that number of table, the table. So for the past 10 lots, or the batch of 16, EQL 2.5, the limit number is 7. Therefore, okay, quality for reduced inspection, the number of conforming in the 600 inspected must be equal to or less than 7. Okay. In some cases, more than 10 lots or batches are necessary to obtain a sufficient number of sample unit for particular AQL as indicated and by notes in the table. It's optional. Okay, let's say 600, AQL was 2.5. So the number must be 7 or less. Okay, 7 or less. Okay, kita tengok di sini 7 or less. 2.5 is 60, inspection was 60. Is it correct? I think so, right? Oh, not 60, 600. 600. What was inspected was 600. Okay, 600 will be somewhere here. Okay, so we will go to 7. You see the number of 7 here? Okay, it shows that 7 or less, only then you can switch to reduce inspection. Okay, so can reduce from normal. You can from normal change to reduce. Okay, after 10 lot of the inspection, okay, after 10 lots which are 600 unit has been inspected, only 7 or less. Okay, 7 or less. Or less. So you can switch. Okay, you can switch to from normal to reduce. Okay, normal to reduce. Okay. Okay. We also have this condition that if the production must be at steady state, no difficulty, okay, such as machine breakdown, no material shortage, and so on, in order for us to allow to be switched. Okay. Reduced inspection is considered desirable by responsible authority. Okay, cannot simply do it as we like. It must be get the approval from authority. The consumer must decide if the saving from fewer inspection warrant the additional record keeping and inspector training. Okay. All right. In the case for reduced to normal, okay, let's say we are now become already reduced, but we are required to go back to normal. Okay, maknanya dah ada kebebasan. Okay, COVID dah tak ada, tiba-tiba ada case pula. Okay, ada case baru. So you cannot have freedom anymore. You have to go back to kawalan yang lebih ketat daripada sebelum itulah. Okay, from reduced become to normal. What are the condition? When a lot of batch is not acceptable. Bila ada lot yang ditolak, okay, kita kena go back to normal dalam keadaan di mana kita sekarang buat dalam keadaan reduce. Okay, any of the 4 condition. Okay. happening. When a sampling or procedure terminate with either acceptance or non-acceptance criteria have been met, the lot of batch is accepted, but normal inspection is reinstated. Okay? When sampling procedure terminated, they either accept or non-accepted criteria have been met, the lot of batch is accepted, but normal inspection is reinstated. Okay? So this is starting for the next lot. Okay, we switch to the normal inspection. Okay, the production is irregular. There are some disturbance, some delay. So we have to go back to normal inspection from the reducer. Other condition, okay, as desired by customer. Okay, yeah, I think that's all related to this. I hope that you also go through this again on your own. Okay, there are examples given here. And okay, so I plan to give you test number 2 1 week from now. Okay, 1 week from now, you're going to have test number 2, which will be on Monday, like this, during class. Okay, so the topic will be covering control chart. Okay, so basically we have control chart, many control chart. We have QSW, you have to review all this. QSW, EWMA. Okay, we have individual control chart. Okay, we have like grouping, deviation from norm control chart. We have, okay, we have control chart for attributes. Okay, so basically test number 2 will cover this aspect of control chartings. Okay, you have the norm control chart, individual control chart, and so on. All right, any question before I stop for today?
What time, sir?
What time? You mean the test?
Yes.
The test will be during class, which is 11:1. Or you prefer other time? The problem is we change the time, there will be some problem of clash and so on. Is it okay?
Okay, Oda.
So next Monday will be, I think, 24th, right? So it is, yeah, 24th of January. Okay.
Masuk dari X-bar chart, sir?
X-bar chart tak masuk. X-bar chart, let me see. X-bar chart, X-bar chart, do we cover the X-bar chart last time for test 1? Let me check. Okay. Okay, test 1. Okay, test 1 did not cover any chart, is it correct? Dah ada control chart. Sorry, dah ada ke? Ini bukan. Okay, can I confirm later? I put it in WhatsApp. Can I put it in Telegram? Okay, I will put in Telegram. What are the chart to be covered? Is it okay?
Okay, Doctor.
Right. So, okay, before I end, can someone help me what we discussed today? Okay, what we do today? Okay, what do you learn today, basically? Okay, Faiz, okay, what do you learn today? Quickly summarize.
Sample size code letter and the table single sampling double apa, for normal inspection, for Titan and reduced inspection,
Okay,
and the AQL, the inspection level, general and special, the switching rules.
okay. So, boleh faham, ha? Ada bahagian yang keliru tak? Any question, Faiz? Is it everything clear for you?